Tim Kang. I'm the principal engineer of culinary imaging for Quasar Science.
Where was Quasar Science, a couple years ago, and where are they today?
So a couple years ago, we started building out these new product line called the Double Rainbow and the R2. Initially, it was a pixelated light, tube light, riggable, data, etc. And then about 2 years ago, I did a research project with University of Southern California. They have an entertainment technology center that does research projects and a working group for different initiatives in industries. So I was part of the virtual production group, and we did a test where we did something called image-based lighting, which is a VFX concept. It's a VFX discipline that's been around for 20 years. Of how do you light something virtually, a CGI model, how do you light that so it looks real? So this technique of image-based lighting is that. We tried to do it in real life using LED tiles in a big LED volume with a big, huge wall, and there were so many problems, obviously. We knew there would be problems. We had to prove it out. And that's when I started to realize what we did here is the perfect tool to start playing it out in real life and actually have it work. So it's been about a 2-year initiative at this point, and we did spend about a year of heavy R&D of being able to correctly interpret video values as color put out by a light. So that's what we hope, not just something that we do, but we want the rest of the industry to start doing this too, because the implications, as you see, will be enormous.
You're taking rainbow tubes,
yeah,
and you're feeding it with different information than you did before.
People have been pixel mapping video to fixtures for a long time, for rock shows, right? So, or live events. So that craft has been around, and every console can do it. They can take video files and pixel map it, and that's how they do all these crazy, elaborate special effects, or live effects. Now, the thing here is, no fixture has ever understood really what those colors were. There's a certain behavior. Video is a language, and there's a certain way that, well, what does a shade of red, what does a shade of blue, what does a shade of green actually mean? And there's a dim curve to it. It's not just straight intensity just increases linearly, or by just increasing intensity. Video encodes it with a certain set of properties. That's basically what we did with the product, is have it correctly interpret the video and tie good spectrum to it so you get good skin tones.
What are you running it through, like this program here?
So this program is called Assimilate Live Effects. Assimilate's the name of the company. It was formerly a software called Scratch. And I was a DIT a very long time ago, and Scratch is well known in the camera side of the world and editorial side of the world, because it's already been a very robust, rock-solid playback program, dailies encoding program, etc. Knowing the video signal is bread and butter, right? And then they realized, all the people doing virtual production, this would be a perfect tool to start driving walls, because they're just big TVs. And then that was the leap. For last year, I think, they put an ability to now pixel map the video and send it to the light. If I move this guy around here, you can see I've sent it around that character, right? Or if I move it over there and I crop it down, let's crop it down, you will start to be able to make out the numbers in the time code. Long story short, it's given this ability at this simple level to correctly interpret the values within the software, because that's a DIT function. What does the video signal actually mean? What are these color spaces? That's the term. And being able to just very simply drag and drop and say, I want, let's say, Princess Peach or this character to be my key light, then I just move the window over, and now that's my key light. That's what the software is. We don't make the software. We just found it to be the best and simplest solution.
How is this talking to those lights? Like, just physically, what's the connection?
It's an Ethernet cable. It's a single Ethernet cable, because it's DMX has multiple carriage protocols over Ethernet. One is called ArtNet, and the other is called SACN, or streaming ACN. So it's basically converting it to streaming ACN values and sending that over Ethernet. And then the lights all take SACN directly, and we can then program out the universes and address everything out properly, and this does it as a piece of cake. It's super straightforward and simple. There's no box.
No box.
It's just straight Ethernet cable from computer to the light.
Yep.
Or if you have a lot of lights, you could daisy chain all of them together. These two arrays right here are daisy chained. It's just passing through the Ethernet data.
Yep.
Now, if you had a lot of lights, then you could actually then get a network switch, from Office Depot or whatever, and that's the box, but it's not a custom proprietary box. Yeah. You're just splitting the Ethernet data out.
Dumb question.
Yeah.
How does this compare to, on the low end, the ProLight ChromaLink, and on the higher end, Mimic from KinoFlow?
Sure. Well, the ProLight is just a different thing, right? It's in an app, and but it is the same thing that you're using a puck to sample a color and send that sample to the light. So that's the same sort of concept, right? Yeah. That's called pixel mapping, right? KinoFlow, with the Mimic, it's actually a display tile. And you need a LED processor to drive it, because that's how display tiles works. So you need to not just buy the tile, you have to also buy the processor, and it takes video signals in directly as just video. Whereas the Simulate can drive that, but it also can drive this. You don't need a Simulate. You can do any media server that can do pixelization or pixel mapping with DMX values or SACN or whatnot. There's a lot of packages out there, like Mbox, Skies, Pixera, it's MadMapper, etc. It's agnostic to that. So you don't need a custom LED processor to create the color values.
Different ways of getting to a similar thing, but there are some specifics that each player is offering.
Exactly. Like the Kino solution, for example, and our solution, and there are other solutions that are coming out from other companies. I don't see that to be a competitive thing. Because they're very different tools. They look different. This is way, way brighter, so you can put it much further away and have large arrays, and as a result, you can have more naturalistic daytime environments, because it's fall off. The fall off is right. With the Kino Mimic tile, you have to be a lot closer because it has less output. Now, that's not a negative, because also if you have the right diffusion on it, you get a really nice, pretty clean image. So if you're doing reflections with the same fixture, that's a great tool. Use both. There's different tools for different reasons, right? I'm in cinematography, and it's not, we never use just one fixture on set. So so that's how I think about it, at least.
What's your roadmap? Where's Quasar going next?
Well, for now, I just put in new color spaces in here to make it more compatible with more available types of video signals. This is a 360-degree driving plane. Now, this is DIT 101. I want to color manage this. Right now, this is a Rec 79 file. Yep. That's the language that the color speaks. So if I know that it's Rec 79, and it's called Gamma 2.4 as a standard, I can then say, let's say I've got a HDR monitor that I'm driving. So I do a Rec 2020, and I do HDR. This is a standard definition monitor. It looks very milked, and because it's log. It's basically log, like when you get a shoot log in a camera, it's this flat look. Yep. And right now, that's also got that flat look on it because it's expecting the language of broadcast, of standard broadcast. So. But we have control space, color space, so I can choose color values, where now this could be more accurately mapping the color. So now it looks like it's dimmer because if you look at the scopes here, it's dim. So when I increase the output on the tile here, so I can increase the gain, and now bring it all the way to the top, that looks washed out, but now that's actually correct. It's mapped correctly onto the fixture.
Gotcha.
Right, and then you can see when I drag it around, it's going to be pretty much what we saw in the original file. Right. Why would you want to do this? Well, you need every tool needs to present solutions, and there's so many different scenarios and workflows, whatever. You have to be agnostic and not tie everything down to just one workflow. We have to be adaptable. So that's what I put into the light as the final extension, what I believe to be what you need to support all these sort of workflows and all these sort of scenarios. And the other final thing is image-based lighting, as I said, is a technique. It's not just on-set image-based lighting is what I call it. It's not just playing video on fixtures, right? I've got a captured plate, a 360-degree plate, that I can map and move around, but also it's got all the lighting data. So when I reduce the values, you can see that the values are starting to come back in the sunset.
Yeah.
Right? So if I go right there, I could then move the fixture over it, and I have all that, and that's not my key light.
Right.
Right? Or if I have a 360-degree environment, I can geographically map this out correctly on the 360-degree environment as this is. And when I then go to a file like this, now I've got a one-to-one accurate recreation of that scene. So if I shoot, let's say, I don't know, a feature, and it was really expensive to shoot, we go to Greenland, right? Middle of nowhere, costs a lot of money to do all that. And what feature does not do pickups?
Right.
Or reshoots? It's a really expensive thing to do. So what you do is when you're on set, when you're on the location there, you do 360-degree video or 360-degree plates, and then you can do pickups in a stage like this, a lighting volume, and map that plate onto all the fixtures, map the background, and then now you could do your pickups. It'll be usually a close-up, medium shot, whatever. That's wonderful. This is how you actually do it for real, and so it's not just doing process work.
Right.
It's not just trickery. Now this is craft. This is real motivated lighting, essentially. So that's where I've been trying to educate everybody in business on this, because it's not just for virtual production now.
Right.
I can do it on any set. I don't need a big, huge array. I can do a smaller array and have it be a better window that I'm using to light me.
Yeah.
So these are the implications of it, on top of all the fun things.
Very interesting. It's deep. Yeah. Thank you so much.
Yeah. Well, thanks for your time.